Good morning, students. Welcome to Brilliant Public School. The topic for today's discussion is indefinite integration. Let us first see what is the definition of integration. A function f is called an antiderivative, that is indefinite integral of a function f in the given interval I, that is f dash of x is equals to f of x for every value x in the interval I. The process of finding the antiderivative of a given function is called antidifferentiation or integration. So it is very clear that integration is nothing but the reverse process of integration. Now let us come to the symbols and meaning of integration. A elongated s, which you can see here, we read it as integral of f of x dx, that is integral of f with respect to x, where f of x is integrand, x is the variable of integration, and integration is nothing but the process of finding the integral. When we talk about indefinite integration, we have a constant of integration which is normally denoted by capital C. Now, let us see integration as inverse of differentiation so that the concept would be clear. Integration is the way of inverse process of differentiation. Instead of differentiating a function, if we are given the derivative of a function and asked to find its primitive, that is, what was the original function before the differentiation, such a process is called integration or anti-differentiation. Now, you already have studied in chapter derivatives. Now, let us see from derivatives how we are going to connect it with integration. That is why the formulas are written just in front of each other for your better understanding. So, derivative of x to the power n plus 1 upon n plus 1 is equals to x to the power n. So, integration of x to the power n dx would be nothing but x to the power n plus 1 upon n plus 1. You know derivative of x is 1. So, integration of dx would be what? The primitive, that is the function itself, that is x plus c. Derivative of sin x is cos of x. So, reverse process means integration of cos of x would be equal to sin of x. In the same manner, you could see there are so many standard formulas which you can very clearly see in this slide. Next, let us come to geometrical interpretation of indefinite integral, where the concept would be clear to you people. Why do we write that plus c? Now see, an indefinite integration of a function always gives family of curves, and these curves may not be similar. So let us see how we are going to get n number of cases, and then why do we write that plus c? Just have a look of this graph. Okay, now you just see, if you see all these parabolas, first y is equals to x square plus 3, y is equals to x square plus 2, x square plus 1, and so on. If I differentiate all these, what do I get, children? I will get 2x. Differentiation in every case would be 2x, but if I go reverse, then all the functions are different. So in this particular case, if I go with primitive, I am getting so many cases there. Hence, as it is representing family of curve, we use that plus c in indefinite integration. Now let us see some properties of indefinite integrals. Differentiation and integration are inverse process of each other. Just now we have discussed, and it is very clear from the formula which is there written there, where c is any arbitrary constant. Now let us prove this statement. Let us see how it happens. Two definite integrals having the same derivative have same family of integrals or curves. Just now you saw the example of parabola, and therefore they are equivalent. The integral of the sum of two functions is equal to the sum of integrals of the given function. So a normal algebra. Okay, integration of f of x plus g of x dx is nothing but integral of f of x dx plus integral of g of x dx. Now let us see for any real value p. Now p is a constant. So if I am having a constant multiplied by integration, that can be readily taken out of the integration. Number 5, for a finite number of functions, say f1, f2 till fn, and real numbers p1, p2, pn, the same property would be applicable. I can very easily take out the constant in each case. Now let us come to methods of integration. First method, integration by substitution, where we substitute the given function as per the need of the question, and normally after substitution we differentiate, and in 90% of cases the differentiation is readily available in the given question. Okay, now see here, if I talk about these all formulas which are shown to you, those are nothing but your trigonometric identities. Now you know very well, we don't have integration of all kind of functions, so then we will have to bring it in the desired kind. So therefore we are going to use trigonometric identities so that we simplify the given function and which can be easily integrated. Further, there are some particular type of integrations. You could see, if I have dx upon x square minus a square, so the value for that is 1 upon 2a log of x minus a upon x plus a plus c. In this manner, the same thing with root and without root. So children, please memorize these formulas very clearly. Now integration by partial fraction, you know, as we have proper and improper fractions, similarly we will have proper and improper fractions where the function would be taken up, and you know very well that the degree of the numerator is less than the denominator, a proper fraction, and vice versa, it would be an improper fraction. So if it is an improper fraction, we will have to use the method of partial fraction, and then we are going to bring it in the desired form so that the integration would be easily possible. Just see, the form of rational function is given to you, and then how we are going to make it in the partial fraction is given in this table. If you see all the functions here, first if you see, it's a linear equation in the numerator and it is the quadratic in the denominator, so it's a proper rational function or a proper fraction. So everywhere in all these cases we have a rational function which is a proper rational function and which can be very easily written in the form of partial fraction. But if it is not, then you are well aware of method of long division which you have learnt in your 9th class. You are going to use that method and you are going to bring the function in proper rational form. Now let us go further. The next part is integration by parts. Now if there are two functions and they are in the form of product, so it is the process that finds the integration of product of a function. So the integral of the product of two function is equal to first function into integral of second function minus integral of differential coefficient of the first function into integral of the second function. So very easily you can memorize this formula. Now integrals of some more type, children, when we will get the use of formulas of circles and ellipse and parabola. So these are some of the integrations which you need to memorize very nicely so that you will be able to find out the area bounded by the curves. So the first and foremost important thing is you need to learn these formulas and keep practicing, because integration or rather calculus requires lots of practice. So keep practicing and keep learning, children. Thank you.